All right, we're going to practice first of all graphing piecewise functions, and then we'll practice writing them. So example 2, we're going to graph this piecewise function. Notice y equals negative x minus 4 if x is less than 0. So I'm going to make a really small table of values, x and y, but I need to be less than 0. So 0 and less than 0. So we could use negative 2 and negative 1 because they're less than 0. If we put in 0, we get negative 4. Notice that's y equals negative x minus 4. That's going to be a line with a y-intercept at negative 4 and a slope of negative 1. We plug in negative 1, we get the opposite of negative 1 is 1. 1 take away 4 is negative 3. We put in negative 2, we get negative 2. Let's check and see if that really is a line with a slope that's negative 1. So we're going to have 0, negative 4. Now I'm going to put an open circle there because the inequality does not include an equal sign. So that's an open circle. We have negative 1, negative 3, negative 2, negative 2. That is a slope of negative 1. All right? We have to have a slope of negative 1 on that piece. So that first piece has a slope of negative 1. All right, second piece. Y equals x if x is greater than or equal to 0. Again, little table of values, x and y. So we're going to start at 0 and we're going to go up. X is greater than or equal to 0. So we're going to go 0, 1, 2. We need values that are greater than or equal to 0. So y equals x. If x is 0, y is 0. Y equals x, y equals x. The x and the y are the same. So what we have is we have the point 0, 0. We're making it solid this time because the inequality has an equal sign with it. So fill that one in. 0, 0, 1, 1, 2, 2, 3, 3, and so forth. There's our graph. We graph it in pieces. The domain, we've got x is less than 0 and x is greater than or equal to 0. So the domain is going to be all real numbers. The range, I want you to look carefully at the range. Negative 4 is as low as it goes, but we didn't include negative 4. We do go up forever, so we're going to have everything greater than negative 4. There's no equal sign because this little circle is open at 0, negative 4. Right? So we don't include the negative 4. We're going to skip over the monitoring progress this time. We're going to go down to how do we write a piecewise function. So you do it with pieces, one at a time. So we're going to start with the left piece. We're looking for an equation for this graph over here. Write a definition of it. Okay, it's going to have two equations because it has two pieces. So the left piece, over here on the left piece, we'll start with it. So it's going to be y equals, let's see, we're going to find the slope of that. It's up 1 and right 1, so that's a slope of 1. So y equals 1x, y equals mx plus b. We have a 3. Notice those are x values that are less than 0 because we've got the little open circle right here, and we've got all the x values that are less than 0. That's the left piece. The right piece, let's do that one. The right piece is going to be, let's see, starting at x equals 0, it's going to go up 2 and right 1, so that's a slope of 2. Y equals 2x minus 1, because our y-intercept is here at negative 1. And that is going to happen for x equals 0 and everything greater because we're over here on 1, 2, 3, and so forth. Okay, now we've finished it off by writing up our piecewise function. So we've got f of x equals x plus 3 if x is less than 0. And then f of x equals 2x minus 1 if x is greater than or equal to 0. And that's how we write a piecewise function.